Hi, I'm Benny D, and in this video we're going to look at the graph, expectation and variance of a binomial distribution. Okay, so we'll start with graphing a binomial distribution. Okay, here I've got just a set of axes with the probability of x on the vertical axis, okay, and x on the horizontal axis. Now remembering our probabilities here are going to be between 0 and a maximum of 1, okay, but we would be unlikely to ever graph anything as high as 1. Okay, and what we're looking at is we've got 10 trials, okay, where the probability of success is 0.2, okay, and we're looking at doing a graph for the number of the probability of each of these outcomes happening. So getting 0 successes, 1 success, all the way up to 10 successes. So since the probability is 0.2, what we find, okay, and all we do is we usually do something like this, where we kind of do a vertical sort of line. What we're going to find is something like this. Okay, where most of our data, okay, is at the lower end because the probability of success is low. Okay, so you're expecting the highest probability is going to be occurring with low number of successes. Okay, and the probability of getting a high number of successes is quite low because this probability is low. And this is what we call positively skewed, because we've got a tail here that points off in the direction of it, the positive numbers. Okay. If we had a look at still 10 trials, but the probability of success this time is 0.5, our graph is going to look a bit different this time. We're going to have a big value here at 5, and then we're going to trail away both directions pretty evenly. Right? Well, incredibly evenly. In fact, this will be a symmetric data set. Okay? Our data set will actually be symmetric here. Okay? And that's just because it's got the same sort of shape both ways. Okay? And our last one, okay, is if we've got 10 trials and our probability of success is 0.8, what would a graph look like? Well, this time we know that the chances of getting a large number of successes is quite high. So this time we're going to be talking about something up here. Okay, trailing off this way. Okay, and so because most of our results are up here for our large numbers and it tails off down this way, we say that's negatively skewed. Okay, because we trail off that way. Now, other things to remember is I definitely haven't drawn this very well because I had this up as 1. Okay, but this is probably going to be something like 0.2 or something, maybe even less. Okay, because the length of these lines added together must equal 1, because in reality, these are the probabilities of each of our different outcomes occurring. Okay, so they've got to add to 1. Okay, so this can't, well, with how I drew it, how high it came up, that can't be 1. Okay, it must be something like 0.2, 0.1, something like that. Okay, so to create the graph, you would need to find exactly what your probability of each of your successes are first. So you've got something to graph. Okay. For our next part, we're talking about expected value and variance. Now this is really nice, much easier than our discrete random variables. Our expected value is simply n, the number of trials, times p, the probability of success. Done. That's it. Okay. Our variance is np times 1 minus p. So the number of trials times the probability of success times 1 minus the probability of success. Or sometimes you might see this written as npq, okay, where q is probability of failure. Okay, so probability of success, number of trials, probability of success, probability of failure. Okay, or you could write it like this. Okay, we've got one last example that we'll have a look at. So an exam has 30 multiple choice questions with 4 answers. A student guesses every question. How many should they expect to get right? Okay, so it should be should they expect to get right. Well, that means that we're doing our expected value, which is simply number of trials, which is 30 times the probability of success. Well, we've got 4 answers for each one, so probability of success will be 0.25, which means we'd expect to get 7.5 questions right. Okay. And what is the variance of x? Well, again, we take this expected value. Okay, we already got what NP is. Okay, so it's 7.5 times by 1 minus 0.25. Right, which is going to be times it by 0.75 again. Right, which is going to give us, I think it's 1.75. I think. Okay, might be slightly up there, but 1.75, something around that. Okay, so you see our expected value and variance is actually pretty straightforward. You can whack this in a calculator, that's no big deal. Okay, so nice and straightforward for finding the expected value and variance for our binomial distribution. Okay, so hopefully that'll be enough to get you through the questions on this section.